I'm Anil Kumar. Welcome to my YouTube channel. In this video, we are going to discuss pattern rule. The question here is, write the pattern rule and then complete the table. We are given an input and output. There are actually two questions here. So if input is 3, the output is 1. For 7 it is 2, for 11 it is 3. You need to find what is the output when input is 63. In question number 2, the outputs are 1, 2 and 3 in a sequence where the inputs are 4, 7, 10 and so on. You need to find the output for input of 58. How are you going to do this question? Well, normally we look at input and output machine in a fashion like this. That this is our input-output machine in which we provide input, let's say I, and we get an output, right? O. Now, in the given case, the outputs are in order. Normally, what we have seen is that the input was 1, 2, and 3, and the outputs were different values. But here, what we are giving you is kind of like this. We are giving you outputs which are in order 1, 2, and 3, and inputs are 3, 7, 11, and so on. Do you see that? So this is kind of a reverse input-output, right? So that is our input-output machine, right? And this is kind of reverse. So we could actually provide you with the rule looking into this reverse operation also. So let us see how to use this knowledge to find the answer. So we are practicing a bit of algebra in this case, right? Okay. So we'll work like this, that this is the output which is being provided. We're doing operation 2, right? So from output, we are going to input, right? So in this case, we can say that the input I is equal to what? Since these values are going up by 4 each time, right? They are going up by 4. We need to multiply by 4. If I do 1 times 4, I get 4. Then I have to take away 1. So I can say that input is 4 times the output, right? Let me write output as this. 4 times the output, it is normally looking like an input simple, minus 1 to get 3, right? So that is how we could relate input and output from this pattern. Now, but we should know what is the output. That is the pattern rule. So we'll rearrange. So to rearrange, we'll do input plus 1 equals to 4 times the output, right? Or we can say input plus 1 divided by 4 is equal to output. Does make sense to you, right? So we get our rule that output O is equal to, you need to add 1 to the input and then divide by 4. Does make sense to you? So we get our pattern rule. So this is the pattern rule. Perfect. So do you see how by reversing the operation we got our pattern rule, right? So we can write here the rule. And the rule for us is that output is equal to input plus 1, and then you divide everything by 4. We'll apply this to find what should be the output when 63 is your input, right? So let's do that part now. So I hope the concept is clear to you, correct? So we got our rule, and we are saying that the rule is pattern rule. Is that output O, the output is equal to input plus 1 divided by 4. So we need to find output for 63. So if input is equal to 63, then what is the output? Well, the output should be equal to 63 plus 1 divided by 4, which is equal to 64 divided by 4. Now 4 times 1 is 4, and then 2, 24, which is 6, 16. And therefore, this should be 16. Does it make sense to you? So we can actually find our result using this kind of reverse operation. Does it make sense to you? Right. So we did the inverse and got the solution, right? You learn inverse operations in higher classes. However, this is a good stage to introduce. I hope you understand and appreciate it. Well, the next question, question number 2, is for you to practice. Now again, the outputs are 1, 2, 3 and so on, but the inputs are 4, 7, 10, 15. 8 we need to figure out. How will you do this? You can pause the video, answer this question, and then look into my suggestions. Well, let's see how the input is varying. Input is changing by, you are adding 3 each time, right? You are adding 3 each time. For the output, which is 1, 2, 3 and so on. Now in this case, we'll again do the reverse operation. We'll work with output to input, right? Of course, if input is giving you some output, output should give you the same input, right? So now we can say, since the outputs are in order, we can say that output O in this case will be related with 3, right? Times 3. So output in this case we need to figure out, but we will start with the input itself, right? So output is 1, 2, 3 and inputs are 4, 7, 8. How do you get these? Well, the rule should be to the output will multiply by 3, right? So we got 3 times the output, right? Let me redo it. 3 times the input. We get 3 times 1 as 3. To get 4, I have to add 1, right? Add 1 to get my input. Do you understand? So I'm writing in a reverse way. I'll go from here to this place. So every output should be multiplied by 3. So 3 times 1 is 3. To get 4, I have to add 1. 2 times 3 is 6 plus 1 is 7. 3 times 3 is 9 plus 1 is 10. So we get this rule that 3 times the output plus 1 is the input. Now from here, we can say that 3 times the output is equal to input minus 1. So we are doing algebra to reorganize. And therefore, the output can be written as input minus 1 divided by 3, right? So that is the rule. So we can now write down the rule which provides you what should be the output for a given input. So we figure out that output should be, from the input, we have to take away 1 and then divide by 3. Correct? Let's test. If input is 4, you take away 1 becomes 3 and 3 divided by 3 is 1. Correct? 7 take away 1 is 6, divided by 3 is 2. 10 take away 3. 10 take away 1 is 9. 9 divided by 3 is 3. It works. So let us also work it out by using the number 58. So if input is equal to 58, in that case the output should be equal to 58 take away 1 divided by 3, which is 57 divided by 3. And that is 3 goes 1 times and 27 is 9. So this number should be 19. Does make sense to you? So that is how we can find our rule. Correct? So that is another way of working for input-output pattern rules. I hope it makes sense. Feel free to write your suggestions, make your comments, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.